All right, this is a recording that I'm doing for 3.1 over sampling distributions. So just know that this is something to watch after you've done the lecture that we've gone over this in class, but it's 3.1 sampling distributions. We'll be talking about parameters, statistics, and we're going to be talking about, instead of just doing one random sample to help estimate a measurement about a population, we're going to be doing several samples and putting them out onto a distribution that might look something like this. Now, this is to help you when you get to the bottom of your homework. There's going to be two exercises where you're going to use StatKey, very similar to these two examples I'm going to do right now in this recording. So the first one is asking us to generate a sampling distribution, where the samples, again, we're going to be doing many samples. We're going to do 1,000 samples, but each one we're going to do of size 5. So they're all really, really small samples of just 5, 5, 5. And this is for the NFL football players, how much average money that they are getting paid, okay, which is in the millions. And so let me get started here. So the data set is, and the tool we're using is here. It's in the sampling distributions, and there's two that we're using for 3.1. You can use one for calculating means or estimating means, and one for estimating proportions. I'm going to do one of each. Right now I'm doing the mean. And so when you go in here, there's really not much there. It's just a blank page with nothing on here. But over here is the actual population. The NFL knows in 2019 that the average, let me switch it to the correct one. That's baseball players. Down here is the NFL for 2019. Okay. And they know that in 2019, the average player was getting about $3 million. Okay. Now, what we could do is, suppose we didn't know, but that was the actual value for the average. We could take samples to try to estimate what that value is, like take a guess at what it is based on like a sample of, 100 players. But we're going to, in this example, we're going to see what happens if we use just 5 players and do many samples. And so you can control the number of cases in each sample up here. You can choose samples of size, and they have it usually at 10 at default, but I'm going to switch it to 5. I'm going to click OK. And so if we were to just do one sample of like 5 random players, up here are your options if you want to do just one sample, 10 samples, 100, 1,000. And so if I just did one sample of just 5 random players, well, here it is. It's just this one little dot. And these 5 players were just randomly chosen. And it's suggesting about 2.9. So pretty good guess. Okay. About close to about the 3 million mark, which is a good guess, because they know that it actually is a little bit over 3. But over here is that one sample of 5 players. You can actually even like click on it and you can see which 5 players were used to try to help guess or estimate the average salary. But to do just one sample, I mean, you can now run like as many samples as you want. You can reset the plot and just run another sample. And now this one is predicting almost 5, which is way off. But the exercise wants us to generate 1,000 samples. And each one of them is going to be 5 players and another 5 players. And so all I did was just click right here, generate 1,000 samples. Again, I can erase it and do it again for you. I'm going to click right here, generate 1,000 samples, ready, set, go. And it generates 1,000 samples of 5 players, 5 players, 5 players, 5 players. And each one of these is its own little group of 5 players, all estimating what the average salary is. And down here in the center, you can see 2.9 million is what's being estimated, and which is a little off from the actual 3 million, but pretty close. And so what you would do in your homework is just describe the shape. You would say that this is skewed to the right. You would also say that it's centered right here at about 2.931. And then you could also up here look at the standard error, 1.8. And I'm going to notate what that is for this example. It's 1.844 because we're going to do it again. We're going to clear it out, but we're going to do this all over again. We're going to run another 1,000 samples, but they're going to be each bigger samples. Instead of 5, we're going to use 50 players in each sample. And so you can clear the board and you can go back up here to the sample sizes and you can say, I want to do 50 players every time I run a sample. You click OK. And again, it's going to be blank until you say how many samples you want to run. So we're going to generate 1,000. Boop. And right away, again, I'm going to do it again, just so you can see it. 3, 2, 1, 1,000 samples. Boom. And so now it's improved. And what I mean by improved is you've got a much nicer bell-shaped distribution of all these 1,000 samples. You've also got maybe a better estimate of 3.023, which is much closer to what the actual value is for the parameter. And you've also got a smaller standard error. Remember the last one was 1.844, and now it's down to 0. I'm going to go ahead and put that in here, 0.610. And so smaller standard errors do represent better estimates for what you're trying to measure. Okay, so that's one of your homework examples, and then another one. So you're going to do it twice, one with the small sample sizes and then one with the larger sample sizes. And you'll turn in you'll turn in your first distribution that was skewed to the right or whatever the shape was. And then you'll turn in your second one. That way you can show that you have both of them. Okay, now the other thing is you can also run proportions. So we're going to do the proportion of US adults that are college graduates. And we're going to use StatKey again, but this time we're going to use sampling distribution for a proportion. And the name of the data set variable we want is college graduates. So when you do this, you go back out to StatKey, and instead of using the sampling distribution for mean, there's also one for proportion. You need to select, if it's not already selected, up here, it's actually the one that we want is on top, the college graduates. And so over here, it is known, at least whenever this data was gathered at this time, that 0.27 or 27.5% of US adults were college graduates. And so suppose we wanted to do a random sample of US adults to predict how many, or to estimate how many were college graduates, we could run samples. Okay, so you can pick whatever size you want, but here they are prompting us what to do. So we're going to generate a sampling distribution using samples of size 10. And we're also going to generate 1,000 sample, not means, but sample proportions. Then we're going to talk about the shape, the center, and the standard error. So up here, it's already set at samples of size 200, but we're going to switch it down to 10. Now, the bigger the number for the sample, for your samples, the better, okay? But just to follow along with the prompt, we're going to do size 10. And then here are your choices. Do you want to run just one sample, 10, 100, or 1,000? Again, I'm going to go with 1,000, and boop, it's going to generate 1,000. Now, some of them are guessing too low, some of them are guessing too high, but you can see collectively they're estimating, they hit it right on the money, right? As a group, all 1,000 samples are centered at about 0.27. It's pretty roughly bell-shaped, maybe a little bit, tiny bit skewed right, but we'll forgive that. You also got your standard error here, the 0.137, and you got your centered at 0.275, which it nailed it right on the money. Okay, so there's your two different new toys to be playing with in StatKey. Again, get with me in lecture during office hours if you got need any help with those two homework problems. All right, that's it. Take care.